Let's start discussing the idea of first ionization. In the earlier lesson, I talked about the meaning of ionization energy. Now you see first ionization energy. This is a heat energy change that involves when 1 mole of gaseous atoms changes to 1 mole of gaseous unipositive ions due to removal of 1 mole of electron. The same thing we can write like this also. This is a heat energy change that involves when 1 mole of gaseous atoms, so far it's the same thing, 1 mole of gaseous atom changes to 1 mole of gaseous unipositive ions due to removal of 1 electron from each atom. See, that's the only difference. So you can remember any definition. First, I write removal of 1 mole of electrons. In the second definition, I say not 1 mole of electron, 1 electron from each atom. Already we are talking about 1 mole. So when you remove 1 electron from each atom, that means you are removing 1 mole of electrons from 1 mole of atoms. In your exam paper, you will get 2 to 3 marks for this answer. Same marks for this also. There are some slight variations in marking scheme. So with those variations, we can go to a maximum of 3 marks, minimum of 2 marks for discussing this definition for first ionization. However, there are a few other things to be inserted into this. If this is done at 25 degrees Celsius and 180, then this energy change is known as standard. Now we are inserting one word. If we can carry out this chemical change at 25 degrees Celsius and 180, we call them standard condition. Then we redefine this enthalpy as standard enthalpy of first ionization. If you want to write first ionization energy, we can write like this: delta H. Change in heat energy. Ionization energy, 1. It means first ionization. Or else we can write delta H first IE. That is also possible. But when it comes to standard conditions, see what is written here. We can write it as delta H ionization energy 1. And we show a symbol over here. You draw a small circle and draw a line across. I can show it better here. This symbol shows you, okay, we are doing this experiment, or we are considering this reaction at 25 degrees Celsius and 180. So how can we define standard first ionization energy? The standard first ionization energy is a heat energy change that involves when 1 mole of gaseous atoms changes to 1 mole of gaseous unipositive ions due to removal of 1 electron from each atom under standard conditions of 25 degrees Celsius and 180. For writing under standard conditions, you get some additional marks. I would rather say 3 marks at least. For the standard definition, you get 3 marks. The following equations show the first ionization of sodium and magnesium. Sodium must be in gaseous form. If give 1 mole of electron, sodium plus gas will be formed. The same as first ionization energy equation for magnesium. Magnesium also must be taken in gaseous form, and you must remove 1 mole of electron. The outcome should be magnesium plus gas. Likewise, you can write the first ionization energy for any element. In a similar manner, we can define second ionization enthalpy and third ionization enthalpy also in a very, very simple manner. We'll go to second ionization energy. Don't forget the first ionization energy. In the first ionization energy, what was formed? Unipositive gaseous ion. Unipositive gaseous ions. Second ionization energy is this. This is a heat energy change that involves when 1 mole of gaseous, not atoms, when 1 mole of gas is unipositive ions, changes to 1 mole of gas is dipositive ions due to removal of 1 electron from each ion. Again, marks are given. Example is this. Mg2 plus gas giving 1 electron, 1 mole of electron, and 1 mole of magnesium 2 plus gas is produced. Third, ionization energy. This is a heat energy change that involves when you remove 1 mole of electrons from 1 mole of gaseous dipositive ions to form 1 mole of gaseous tripositive ions due to removal of 1 mole of electron or 1 electron from each atom. Example is given. Magnesium 2 plus gas giving 1 electron and magnesium 3 plus gas. There's a small work for you. This is identified as question number 6. I'll give you 2 minutes to do this work. Please do it. See whether you have written the same thing. Question number 6. Third, ionization of aluminium. For the third ionization, we have aluminium 2 plus, aluminium 2 plus, removing 1 mole of electrons to give aluminium 3 plus. Second and third ionization of aluminium means you have to start after first ionization. First ionization gives aluminium plus. So afterwards, second ionization gives aluminium 2 plus, third ionization gives aluminium 3 plus. So when we add them together, we get the answer. If anyone has a problem with this, okay, you can just write 1 or 2 equations and see. Here, what is the first ionization for aluminium? Aluminium gas. Or else I'll start with second. Second ionization is given as aluminium plus, giving aluminium 2 plus 1 electron. Third ionization means aluminium 2 plus gas giving aluminium 3 plus electron. Now this is second ionization. This is a third ionization. When you add them together, first and second one, second and third one, when you add together, aluminium 2 plus cancel with aluminium 2 plus, and we have aluminium plus gas here, aluminium 3 plus gas here, and 2 electrons together here. So this is the second and third ionization of aluminium shown in a single equation. Same way we can find out first ionization and second ionization for magnesium also. Shall we do it? First and second ionization for magnesium. Magnesium gas give 1 electron and magnesium plus gas in the first ionization. And in the second ionization, magnesium plus gas give away electron and change to magnesium 2 plus gas. When you add them together, you will see magnesium plus gas will cancel out, and we have magnesium gas here, 2 electrons here, and magnesium 2 plus gas here. If you want, we can write individual ionization equations and add them together. Or if you're experienced, we can straight away go to the final equation. But before going to final equation, please practice this a little bit so that you will know exactly what has to be done. Okay. All ionization values are endothermic. it means we had to supply energy. Why do you think we had to supply energy? Because ionization involves bond breaking. What bonds? Bonds between electrons which are removed and the nucleus. There are attractive forces. We have to overcome them and pull the fellow out. Ionization energy values increase successively. What's the meaning of successively? When you remove electrons one after another, first electron, second electron, third electron, fourth electron, the amount of energy needed will increase gradually. Why? It is because when electrons are removed, ionic radius decreases due to two reasons. Ionic radius decreases. First one, when electrons are removed, repulsion among available electrons decrease, moving closer to the nucleus. And when electrons are removed, energy levels also can be lost. You get it? When you remove electrons, the first point, if there is an atom with some number of electrons, if you remove one electron, the number of electrons will decrease and the electron density will decrease. If the electron density decreases, repulsion decreases. So electrons can come bit towards closer to the nucleus. And also, in some cases, when you go removing electrons, at a point you will see you are entering the inner energy level because outer electrons have been completely pulled out. So when you go to an inner energy level, then energy levels are less, electrons are more attracted towards the nucleus, and size of atoms will be lesser. Here, when ionic radius decreases, I'm reading this point. When ionic radius decreases due to the above two reasons, available electrons are attracted towards the nucleus more, at the same time increasing the attractive forces between the nucleus and the available outermost electrons from where electrons are removed during ionization. With all these information in mind, we can go to the next part, where let's talk about how first ionization energies vary across the period and down a group also. I have not explained much of it yet. Of course, certain things I have explained from here and there. Now we'll try to pull them together. However, the summary you will come across at the end of this lesson will be: first ionization energy increases across the period, and first ionization energy decreases down. Having this in mind, okay. Having this in mind, we will go to the next part. First ionization energy values are important evidences that help us to predict the presence of sub-energy levels in atoms. For these studies, we analyze the energy levels to cause first ionization elements across period and down the group of the periodic table. Now, we'll see. Why does the first ionization energy increase across the periods? How do we know that? I have given the fact at the beginning. First ionization energy increases across the period. Now we'll see in detail how we can discuss it. We'll see what we have to talk about here. We can discuss this observation. What is the observation? Across the period, first ionization energy increases. We can discuss this observation by taking period two elements. What are the elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay. According to how I have shown here, atomic size decreases across the period. What is the reason now? Now we can pull all the things we have discussed so far to explain this. Why atomic size decreases across a period? Reason. If you take elements in a single period, now here we have period two elements and all have two energy levels. Only two energies are there. The number of energy levels remains the same across the period. Or the number of inner electrons remain the same across the period. In the exam, you can write one of these points. Anything which is convenient to you, what you can remember, you can remember. I'll read again. The number of energy levels remains the same across a period. Yeah, that's quite obvious. Don't just ignore this thinking, anyone knows that. Yeah, for that knowledge, you get 1 mark. See, 1 mark. It is not enough. Second point, shielding effect remains the same across a period. I have a question mark because in certain exams, this is not accepted for a point, but in some exams, it is taken as a point. So it is better whether you get this mark or not, you write this sentence, because in your marking scheme, if it is a mark scheme in point, you lose a mark if you don't write it. So first one we write, number of energy levels remains the same, therefore the shielding effect remains the same. Okay. However, see the number of protons lithium has. I have written the proton number in this dark circle inside. Lithium has 3 protons. Next one has 4 protons. Boron has 5 protons. Carbon has 6 protons. Likewise, the proton number increases. What happens when proton number increases? Because the shielding effect is the same, when the proton number increases, the effective nuclear charge increases. I have given the third point. The number of protons increases or the effective nuclear charge increases across the period. I think it is better to write both. The number of protons increases, therefore the shielding effective nuclear charge increases across period 1. Across the period. 1 means the mark. Therefore, electrons get attracted towards the nucleus more and more, and the outermost electrons come closer or the radius decreases. See how you get marks. First mark for telling the energy levels are the same and the shielding effect is the same. 1 or 2 marks. Second mark is for telling, because proton number increases across the period, effective nuclear charge increases. And then we say electrons get attracted to the nucleus more and more, and the size of atoms decrease. Please put some effort and try to get not the sentences by hearted, get the idea. Get the idea and read the sentence. Then your idea plus a sentence, they will blend together. You can write the answer without a mistake in any exam. We had to use so much of effort to remember this. If you don't get the idea. Now we go to the next one. This is about variation in atomic size across a period. Now we talk about variation in size down the group. The question says, why does first ionization energy decreases down the group? First one was about, why does first ionization energy increase across the period? Actually here, you had to insert one more point. Electrons get attracted towards nucleus more and the outermost electrons come closer. And one small sentence has to be written. Shall we write the sentence for that? Write the 4th point or 5th point here. More heat energy is needed to remove electrons across the period. Insert this. Because we are talking about the attraction of outermost electrons to the nucleus and then variation in size, but we don't talk about the first ionization variation. More heat energy is needed to remove electrons across the period. Therefore, first ionization energy increases. Now here, in this point, why does first ionization energy decreases down the group? The diagram shows very clearly. Moving down the group, the size of atoms increases. Why size of atom increase? Because energy levels are getting added. When energy levels get added, shielding effect increases. In addition, the distance between the nucleus and the outermost energy level also increases. So there are 2 points. When the radius increases, outermost electrons go further away from the nucleus and moving down the group. When a number of energy levels increase, shielding effect also increases. Because of these 2 reasons, outermost energy level electrons are attracted to the nucleus less strongly and spending lesser amount of energy. We can remove electrons for the first ionization down the group. But in the exam, how are we going to write? How are we going to explain why first ionization energy decreases down the group? We have to explain point by point. I have given what happened moving down a group. The number of energy levels increases. Yeah, it's seen here. When the number of energy levels increases, the distance between the outermost energy level and the nucleus increases. Moving down the group, the number of energy levels increases and the distance between the outermost energy level and the nucleus increases. The increasing, second point, okay? The increasing inner energy levels increases shielding effect also. When you go down, more energy levels come. So more electrons are there. As a result, shielding effect increases. At the same time, the number of protons in the nucleus also increases. Hence, nuclear charge increases. See what I'm going to write now. But the increase in shielding effect overweighs the increase in nuclear charge. Moving down the group, why do I talk about nuclear charge? Because I talk about nuclear charge across the period also. Across the period, see here, across the period, proton number increases. Therefore, outermost electrons are attracted stronger and more energy is expected to remove electrons across the period. Now down the group also, number of protons increase. Even though the number of protons increases, because of the increase in shielding effect, the influence of the increase in proton number is not going to be much of a big important thing. We say increasing nuclear charge is overweighed by the increase in shielding effect. So shielding effect becomes more important in this. So shall we go to this again? But the increased shielding effect overweighs the increase in nuclear charge. I'm reading this point. Hence, mainly due to the increased shielding effect and the increased atomic radius, the outermost electrons are attracted to the nucleus less strongly. Hence, removal of an electron for the first ionization decreases down the group. Now, there are so many things. You may wonder whether we have tried everything for the mark. No. Shall we try to pull all this information and write a simple answer? Not simple, it's the same thing, but then without this many points. We can write due to the number of see whether you can remember these sentences in a single sentence, okay? All these points I have taken into this. Due to the number of increasing energy levels and electrons, the atomic size increases and also the shielding effect increases. The increase in shielding effect overweighs the increase in nuclear charge. Hence, the outermost electrons are attracted to the nucleus less strongly and less energy is needed. Less energy, or we can say lesser energy. Lesser energy is needed to remove electron. Yeah, if you can remember this, I think it's better. Okay. Now, again, I'm talking about the summary. The summary of the above discussion is that the ionization energy increases across a period. The ionization energy decreases down a group. Please remember. So in this part of the lesson, I try to explain to you how we can explain the general variation in first ionization energy across the period and down the group. And for this variation across the period and down the group, I have taken two things into consideration: effective nuclear charge and shielding effect. How the variation of shielding effect and atomic size across the period and down the group should be understood very well. And with the help of it, you should be able to explain why ionization energy increases across the period and decreases down the group. This is a bit of a writing part. In O-level, you like to get 1 mark for 1 word. That's a trend. But when it comes to A-level, you can't do it in that way. You have to give your ideas in clear language so that the examiner can understand what you exactly mean, and that gives you marks. So this part completes my intended lesson discussing about effective nuclear charge and shielding effect.